There's 3 or 2.
3 or 2?
Wait, is that like a
Is it, yeah, I was gonna ask
Start from
transport
bottom.
layer.
I think
No.
it might be transport layer, but you know what, I'm going to look that up.
I can also see this being a link layer because it actually.
Cause that's like the
is
protocols
initiating.
though, right? Like the transport's the protocol layers, right?
Yeah, looks like TCP and UDP. Transport that.
It's application layer.
It is application layer.
There you go.
Man, we were
No,
all,
you got
we were
application
way
layer.
off.
Whatever. Wait, what?
You know, I also thought it would be transport layer because it seems like it happens beyond application layer. Did you have a question?
No.
Okay.
Alright,
So I have a question
Everybody
about
said
that.
from layer.
Because it's handled in the application layer, is this like using DNS be something we'd have to actually incorporate into our code immediately, or would that still be handled through something that's not in our field of control?
I don't think you would have to handle it within your application code. I think this is something, DNS is something that gets, so I think that DNS just, is a separate application that your code will end up using, but you don't have to do it on your own. So, I guess, so does everyone understand the general concept of name servers and how name servers play into translating a domain name to an IP address? Okay. So the next step is that there's 2 different types of name servers. There is authoritative name servers. I might have spelled this wrong. And non-authoritative name servers. So like from our Clemson example, if we contact a name server that is within our Clemson network, it's a name server. So if you have your laptop in front of you and you go to etcresolve.com,
Is that on the virtual machine?
yeah, so on your virtual machine, you should be, when you go in here, you should be able to see the name server that your virtual machine is using by default that it got from Azure. So if someone sees that, let me know. Is someone logging in?
I'm working on that.
Go start up.
Do you see it?
Yeah.
What do you see?
The name server's on localhost.
Okay, just localhost. So that means it's just using a local cache, and we can get to that in a little bit. So an authoritative name server would be if we were in the Clemson network and we used a machine within the Clemson network that had information directly from the domain manager. So it has first-hand information of what domain connects to what IP address. When you get your information, when as a host you get information from such a name server, that is called getting information from an authoritative server. And each domain, so like cs.clemson.edu, depending on how you have set it up, will have at least 1 authoritative server attached to it. A non-authoritative server is, let's say, so all these, let's say there are all these name servers. So for each of these domains, there's a name server. And they're all connected to each other. So let's say instead of getting our information from, let's say within Clemson we have a CS and we have a CCID, and we want to get some information from CS, but we are using our local name server is the CCID's name server. So if we ask the CCID's name server about how to access this netlab.cs.clemson.edu, and the CCID name server queries the CS name server on our behalf and gives us that address information back, then that information is coming from a non-authoritative server. So that information is coming to us from a server that doesn't have the direct information by itself from the domain manager, and it gets that information from another name server. So that's basically the difference between authoritative and non-authoritative name servers. Does anyone have questions on that? Yeah.
So I can like host my own domain server, my own DNS?
Your own DNS on, if you have your own home network,
Yeah, I can
you
have my own.
could.
Right. So can I like, how do I explain this? It's like, okay, yeah, here's a good one. So if I, at your house, if I go in your router and I change the DNS it connects to mine, then when you get on like, will it redirect all your traffic to my DNS? That makes sense?
So you're saying, will I be able to access anything, any domain names that you have on your local host if I am pointed to your DNS server?
Yeah, through your router.
Right. If we have a way of connecting, if we are connected, our subnetworks are connected,
Yeah.
I could.
Okay, that's pretty cool.
I think I could.
Okay.
If our subnetworks, if we have a way of reaching each other. So like if you're not connected to Azure Home and you try to do we'll talk about Whois in a little bit if we get time to talk about it, but that tool, it also uses DNS name servers. If you're not in Clemson network and you do Whois netlab.cs.clemson.edu, it won't be able to tell you any information because that's internal to our network and it doesn't know how to get to it.
Okay, yeah, that makes sense.
That answers your question?
Yeah.
Okay. Does anyone else have any questions? Okay. So, there's one more. So we covered name servers and we covered authoritative, non-authoritative name servers. There is one more important concept to know about DNS. I'm not sure if Dr. Martin was going to get into it, but I'll just go over it briefly. So on the client side, on the side of the host that wants to know the name server information, it's called the application, the software that runs there is called a DNS resolver. And on the other side, you have the name server. So what the DNS resolver does is that it sends out the request that needs to be resolved by the name server. So let's say our local name server is an authoritative server on what our host is asking for. It can then directly return back with the answer in an authoritative fashion. Also, when you do the homework and you get to the dig tool, remember that anything that comes from an authoritative server has a flag A set on it. AA actually, not A. So that's how you know that a server is authoritative. That's one of the questions in which you have to figure out if the response is coming from an authoritative server or not. And you have to look for the flag AA.
Is that basically how like certificates work?
I think that, how do you mean?
Like, you know, if you go to google.com, you know it's google.com because it has a certificate that's signed off by all these other things that say, yes, this is google.com.
Oh, no, I think that's a entirely different layer
Alright.
7 concepts. It might have some similarities in functionality, but as far as I know, DNS has got nothing to do with the certificates.
So what did you say the difference between authoritative and non-authoritative was?
So authoritative server, so if your request is being, if the response you're getting is from an authoritative server, that means that the server has first-hand information of what you're asking. So that server, through your own domain information, like the domain manager, where the database of all the domain names and corresponding IP addresses is kept, it knows firsthand and the information it's giving you. That's authoritative. Non-authoritative is if your name server has to contact another name server from which it gets the IP address mapping to the domain name and it sends it back to you. So what I was going to say here was that when your name server gets a request from the DNS resolver, if it knows the answer, you get it back authoritatively because the name server knows it. If it knows firsthand, or if it has it stored in its cache. That's another important concept. So name servers are allowed to have a small cache of the things that have been requested recently for a given time period, and if it has that request in cache, it can send that back to you, but that would be non-authoritative because that's not information from itself. But if it does not at that point have the means within itself to answer that request, it checks for one of two things. It sees if the request is marked recursive or if it's marked iterative. These are the two kinds of requests the DNS resolver can make.
I might not be able to phrase this too clearly, but if, whenever I go into my router settings at home, I notice that all my devices have a certain release time associated with them. Does that mean that the DNS server that I'm using has my device linked to whatever my local network is in the cache of their DNS server?
Oh, so that lead time is a concept we are going to cover in DHCP. DHCP is when you cover DHCP, we'll get through it, that when DHCP gives you an IP address, which is basically what it does, it also gives you the DNS name server you need to connect to. So at the time that the lease time you see, at the end of it, DHCP renegotiates it and you'll get the DNS name server again. Most likely you'll get the same one, but it's not a given.
So what did you say has an iterative or recursive?
Oh yeah, I was going to get to that. So iterative and recursive are the two types of DNS requests that your host can send out. They can either be, so in, I think, it might be in the homework, but in the DHCP client or DHC client config file, you get to specify if you want to be recursive or iterative, if you have that much control over network. If you request a recursive resolution of a domain name to an IP address, then the local name server first checks if the name lies in its own domain or subdomain, which is the step I described here. And if it doesn't, I'm sorry, I think I was going to say the wrong thing. So if it's a recursive request, then it will, and it doesn't find the domain name resolution within itself, then it will query which other name server has that information and tell you to contact that name server. So I'm going to erase some of this and draw this. So let's say this is your host, A, and it sends the request to its local name server. And it makes a recursive request and not an iterative request. And the local server does not have that information within itself. The local name server finds out what name server that would have that information and sends you back that try this other name server 2. Then you have to send the request to name server 2. And if name server 2 has that information, it sends you back the resolution. If it doesn't, it says try name server 3. And name server 3 is the IP address to the name server it knows would have more access to that information. And here you refer to this top-down tree. So host A contacts its local server and it can't find it. So it tells you what is the next best server to reach.
Does this mean that the recursive and iterative means of finding the IP address only come into play when we're dealing with a non-authoritative DNS request?
Right. Because if it's authoritative, you don't have to go to a second step at all. So that is iterative. What recursive is when you don't do all of this. When you do a recursive request, it's easier. You tell your local name server, I want the IP address for this domain name. It goes and it contacts the next server, which contacts the next server, which sends back information, and all you see is an answer back, even if it's non-authoritative. So that's the difference. There are possibly benefits to doing both of those, I think, depending on how much control over your information you want.
So how does it know what the best next DNS is?
Oh, okay, that's a good question. So all the name servers starting from root onwards. So there's a root name server. Traditionally, all requests start from a root server. So when I ask my server for something, for let's say I ask CCIT, I ask the name server in computer science that I want to go to cs.clemson.edu. So it looks at it from this end. It says, okay, we have edu. It goes to the root server and it says, tell me which server has information about edu, which takes us to this name server here, because each of these levels has information about all the name servers that follow the level below. And when we are in edu, we ask edu, which of the name servers do you know of that connect to clemson.edu? And that's one way of doing it. But this would be very problematic if every request had to go to the root server. So they have local caching. So let's say I did this once. Now clemson.edu knows how to now edu knows how to get to clemson.edu without actually having to have that information all the way from the top. So the process is this, but based on local caching, all of them know based on frequent requests coming in who they connect to. Does it make sense?
Yeah.
Okay.
So this is DHCP.
No, this is DNS.
This is still DNS.
Yeah.
Okay.
Wait, how are we doing on time? Okay. This is DNS, and these are the important DNS concepts. There is the concept of name servers, authoritative, non-authoritative, recursive, and iterative resolution, and what the DNS resolver does versus what the name servers, and the hierarchical structure. So I have them all in the notes also, you can look at them. Now we'll go on into DHCP. Does anyone have any DNS questions? No? Okay.
So that was the DNS resolver that you just showed us.
The DNS resolver just sends out the request.
Okay.
That's the DNS process. Most of what we talked about, so the DNS resolver, the only two parts it concerns with is marking the request as recursive or iterative. Iterative is also called non-recursive, so if you see that, that means the same thing. So it is DNS. Now DHCP. So when your computer boots up and you connect to, let's say you're on campus, your laptop, I call it host A, it boots up. There is this process that happens within it for it to be able to get an IP address from Clemson University's Azure own network. And how that happens, how from your host booting up to it being able to get an IP address and being able to communicate to other Clemson University hosts and the wider internet, the protocol that is used for that communication is called DHCP. It's called Dynamic Host Configuration Protocol. It works in a client-server fashion where your host has a DHCP client on it, and your wider network would have, given a network the size of Clemson's wireless network, it would have a whole bunch of DHCP servers whose job is to maintain the list of assignable subnets and IP addresses and which ones it can give to you. That's the general concept of DHCP. So your host runs a DHCP client and the DHCP is run on a different machine. In your home network, the DHCP server is most likely run in the router. So if you like to tinker around and you go into your router, and most routers come with GUIs. So if you go into your router graphical user interface, you should be able to see this box in advanced settings that says DHCP settings, and you can assign a 192.168 something, a class C subnet, a local subnet actually, that you can say assign from just this subnet to the devices in my house. So the process when a host is, let's say there's a host and a DHCP server, and your host has just booted up. It has no IP addresses at this point, and this is progression in time. The first step that happens is that the host will send a discover request. And I think one of the questions in homework 2 looks at the TCP packet dump, and when you see these packets on it, they will be marked with DHCP discover and DHCP, what's the other one? DHCP offer, DHCP request, so you'll be able to tell what you're looking at. So you send the host sends a discover or a DHCP discover message to any valid DHCP server on the network. The network then, the router, if your DHCP server is not on the router at this point, it will redirect it to the valid DHCP server it knows of, and your request will reach the DHCP server. The DHCP server receives the packet and finds out what is an appropriate IP address to send back, and it will then temporarily block this address to be given to anybody else and make a DHCP offer to the host. The host looks at this offer and sends a request. If the IP address is okay with it, it sends a request to be assigned this IP address. And then the DHCP server sends an acknowledgement that this host has this IP address for this time duration. And the time duration that it sends it for is where the concept of leaves comes in. So the leave you see is the duration for which you get an IP address from a DHCP server. So for a network like Eduroam, where people are always connecting and disconnecting, you would get a lease for, let's say, less than 1 hour, and then it would be up for renegotiation just in case the IP address is free. What do you guys think would be a benefit of having a shorter lease on a network in which a ton of people are connected at all times?
You're refreshing which addresses are assigned and not assigned more frequently, so it essentially lets you accommodate a larger group of people.
That's
with
correct.
that network.
That's correct. That is because that's optimal. You're not wasting any IP addresses. You have a pool of IP addresses, and you're trying to make sure that at any given time, as many of them as you can keep in your repository which are free to be assigned are free to be assigned. So, and the other important thing is a question that, so remember I said that this happens right at boot up. You don't have an IP address yet. How do you think this discover message is going to the DHCP server since you don't have an IP address?
Would it go through your router? So your computer would be connected to the router on a, I guess, lower level than the actual internet. It tells that router that, hey, I'm a device with this MAC address. I want an IP address. So the router then kind of does the legwork for you to go and get that IP address and relays it back to you. So you don't have to have that initial IP address on your device so that you can connect to the internet.
That would have been correct, but with what layer is DHCP? Does anyone know what layer DHCP is? It's
So-
layer 2, I think.
It's
one of the
7.
layers.
It's what?
7
It's 7?
application.
Oh, I am like inadequately informed in the things I'm trying to teach you guys. So, but DHCP is layer 7, so it needs an IP address. So what you are saying, I was trying to verify what you are saying is possible. So from getting from layer 7 all the way to the MAC layer and the physical link layer, for it to traverse the entire stack and then go out to the DHCP server, it would at some point need an IP address to form a packet, which it would then convert into a frame here. So even if you were connected to a router directly and you were able to send a MAC frame, an IP source and destination would need to be encapsulated in it. So not that. Does anyone have any other guesses of how it works?
How like DHCP works?
No, how the host, without actually
Oh.
having an IP address,
Isn't that how ARC basically works? Does ARC not do that?
No, so
ARC
ARC only converts, you guys are making me give away the good parts of the next thing I was going to be. How ARC basically works is it gives you the MAC address corresponding to the IP address. But at this point, we don't have an IP address.
Oh, okay.
This is just a guess. Does it use your local host in any way, or?
No, but you are in the right vicinity, it uses one of the special addresses, it uses the broadcast address.
Okay.
Yeah, that would have been a good guess. So even if you don't have an IP address, your software knows your IP stack, TCP IP stack knows that it can send information using the broadcast IP address. So it can send information using 255. So it sends a broadcast address. Your router gets it, sends it to the DHCP server, and that's how you get all the information. Another important thing is, let's say you're working on a host on which you want a static IP address. DHCP allows you to do that. You can specify the type of address you want. It supports getting a static IP address, getting an automatic IP address, and getting a dynamic IP address. So a static IP address would be where I have a specific IP address from the subnet in mind. Let's say we have a 130.128 something subnet, and I say I want 9.9, and this is the only address I want. I can ask for it. If it's free, I will get it from the DHCP server. When I make an automatic request, it is like getting a static IP address, but I can't specify which address I want. It will give me one address and I get to keep it. In dynamic, it gives you whatever address is available, and it renegotiates it time and time again. So I guess these are all the important concepts in DHCP. And then we already went through some of it here, the concept of lease negotiation.
So if we're developing a server that we want different things to connect to, we wouldn't want to use DHCP because that means the IP address of the server will constantly be changing. So we want to keep it with a static IP address?
Yeah.
Okay.
Yeah, that's correct. And your DHCP server would be able to do that,
Okay.
give you a static IP address. And we went through the concept of leases earlier. So the important DHCP concepts are, you need to know these packets are what is exchanged to get an IP address. You need to know that the lease is negotiated in a given time period. You can, I think, somewhere in the etc directory, there is in your DHCP configuration, you should be able to see the lease you have. The DHCP service on Linux is called INC DHCP server and maybe client, but that's something very easily, you can look it up very quickly and you can see if it's working on your system or not. In the information in the offer that it sends, DHCP, how it connects to DNS is, in the offer that your router sends, your router knows where your name servers are. It needs to send to your local host that when it looks up a domain name, which name server to look up in initially. So the offer along with the IP address includes the subnet mask, your network ID, and your local name servers. So your DHCP is how you get your initial DNS information from name server. So that's how your machine knows where to make a DNS request to. Does anyone have questions on DHCP?
So, is NAT related to that? Oh,
No?
To DHCP? No,
Yeah, okay.
NAT isn't. DHCP is just you getting an IP address. NAT is something you do at your host end to kind of convert a internal IP to an external IP. You're at a machine at the edge of your network.
So DHCP gets you an IP address already for a like remote host.
DHCP gets you no, not a remote host. DHCP gets you an IP address from a set of IP addresses that are assigned to you, your organization at large. And when I say organization, I don't just mean like Clemson has a set of IP addresses and DHCP gives you one of them. For your home network, let's say you have AT&T. AT&T has a set of IP addresses of which a smaller set they have assigned to your location, of which a smaller set they have assigned to just your home. So DHCP helps you get an IP address from that subnet.
So what happens if there are, like, say, 100 available IP addresses and 300 of those try to connect at the same time?
Oh, then hell breaks loose. Yeah, that's, I mean, you would want to provision the number of IP addresses you have to always be less than the number of hosts that are connecting at each point. If a host cannot get an IP address, then I think there are timeout requests and you're not able to connect and you have to resend the request. But I can, that's actually a good point. I did have it in my notes, but I will add it, what happens when something like that happens before I ask Dr. Martin to post it.
Okay.
So that's DHCP. Obviously, that's something. So now we know how our machine gets the IP address when it boots. We know how a domain name is converted to an IP address. ARP is, and this one I know for sure, is layer 2. So ARP is Address Resolution Protocol. What it does is, we just went through it a little bit. So you have so let's say we have UDP ping. In it, the packet that's formed, it has a source IP and it has a destination IP. We send it and we get a reply back from another source based on just this source IP and this destination IP. But how it's going through a protocol stack is, it goes to the MAC layer, link layer, and then onto the physical layer, and then it goes all the way to the other host, where it goes through the physical layer, the MAC layer, and it then goes to the IP layer, and there is the source IP, destination IP, and based on that information, all we are seeing is that we specified this destination IP, it goes here, it comes back from here, but what's actually happening is all of this. When our packet goes to our MAC layer, the source IP and destination IP get encapsulated, so this message gets encapsulated. Are you guys familiar with the concept of encapsulation? Okay. So it's just where the packet gets encapsulated in the literal sense of the word in another bigger packet with different information. So at the MAC layer, we have the source and the destination hardware address. So the MAC address. And that's what's used to transmit the packet from the MAC layer to this, our host piece MAC layer all the way over here. But for each of the, so we know our own source MAC address. We don't know the destination MAC address. And keeping track of the MAC address of everything in your network is a lot harder than keeping track of the IP address of where you need to send to. So that's something you can't do. You can't maintain a map of everything, every MAC address on your network. So ARP is a really nice protocol that the TCP/IP people wrote that lets you get the MAC address of the IP address you want to send information to. So at this point, you know what your destination MAC address is. How it functions in a really simple way. So at this point, your IP, where you have the IP address, you send out a broadcast to everyone in your network where you say who has, and it's called a ARP request. And you ask who has the MAC address corresponding to this destination IP address. Everybody in your network will get that, message, but only this IP will recognize that it has the MAC address you want, and it will reply with a ARP reply. When you ping a network that is not already, that you haven't, yes.
So you said it'll send out a credit request like who has this IP address or MAC address?
What, say that again?
Or would you, right there, did you say it sends a ping out and it says what?
Oh, so, at the IP level, when you only know the destination IP address, your host will send a broadcast to everybody, and it will ask who has the MAC address corresponding to this destination IP address. That message is called a ARP request message. It's a small message.
Okay, so what happens if I'm not the person with that address, but I still reply back to that and say, I am that person?
That's a spoofing attack.
Yeah, so is that how man in the middle works?
Yeah, that is one way of doing man in the middle. That's also one way of doing spoofing, where
Yeah.
you tell someone you are the MAC address they send to you and the message is not destined for you.
And then you just send it back to that, okay.
Yeah, if you forward that message with malicious intent, that's man in the middle. If you just do that to listen in on conversation, then you are spoofing or eavesdropping.
Yeah, okay. I thought that's what it was.
So
Same
that
thing as packet sniffing.
packet sniffing.
I saw that in the textbook.
Oh, packet sniffing is, well, what he was talking about is malicious form of sniffing, where it's information you shouldn't be getting, but you are getting. But for packet sniffing, you can legitimately listen on a port if that port allows it.
Can you tell when somebody, I guess, if you pretended to be that MAC address and you started receiving their packets, could you tell that somebody else is using your MAC address?
So I think it's really hard, I think.
Maybe, I mean, if you had checks in place the way you had set up, but you couldn't tell just based on what we are talking about, you wouldn't be able to, if you were a naive machine.
So since ARP is like so simply written and stuff, is there, it doesn't have any checks in place to prevent this, right?
I don't think it does, but it depends on checks at higher layers to kind of check the information is going to the right place. But, so one of the common networking projects that actually people do is to create an ARP variant where you would be able to tell if your MAC address is being misused. So that's actually one of the projects in Dr. Martin's other grad class that we did. So you could do that for your project if that's what you wanted. It's really cool. Okay, so I am going to ask the question I asked earlier here also. So when the IP sends a broadcast message, that broadcast message also needs to be encapsulated and sent through the MAC layer. If you don't have the MAC address of the machine you want to send it to, how is that packet going out? Did my question make sense?
If you don't have the MAC address to where it's supposed to go?
Yeah. When you broadcast it, so I am broadcasting it, how does it get out of the MAC layer? What destination address is specified for my broadcast packet?
Or if you're broadcasting, you're going to all hosts on that network. So is there a special MAC address to mean just any host?
Yes, that's the part I wanted to point out. There is Ethernet also does broadcast. The way we have 255s, all 255s and all ones at the IP level, we have all F at the MAC level. So FF, that is the Ethernet broadcast IP address. And one last thing I'll say, I wanted to go over whois and dig also, but I don't think we have enough time for that. One last thing I'll say is when the ARP reply comes from host B, it doesn't just come to who asked that question. It goes to everybody on the network so they can add it to their cache. So that the next time they need to send something, it's something that's already in their cache and they don't have to send broadcasts. Because that many broadcasts sent on the network can be really costly for the network. And if you want to see what's in your local cache, you can do ARP-N on your terminal and you should be able to see it. And just do man ARP and you'll see a ton of cool options to see what MAC addresses your network knows of.
So that broadcast only goes to like a specific I guess you would go a specific subset of the network, PLCO.
Yeah, just to everything you can connect to, like everything within your network. So not like everybody in the wider network, everybody on the World Wide Web. That's what
Oh,
you
okay,
mean?
yeah.
Yeah.
So what kind, so you're saying a MAC address, what kind of a difference is there between the MAC and the IP address? Like what type of address? Like how many MAC addresses are there, that kind of thing?
So a MAC address is unique to every machine in the way an IP address is not unique to every machine. I went to